Hey everyone, my name is Danish Hussain. I'm a solutions engineer at Wiz, and today we'll talk about how we can enhance your cloud native security by leveraging speed, accuracy, and context to effectively respond to threats. Now, it's no secret that the cloud has changed and continues to change everything. The biggest question security practitioners have to ask themselves now is how do I get visibility into my environment? The cloud is great, but it introduces a lot of challenges for security. Developers are leveraging new assets, new services, new architectures. There's multi-cloud deployments, hybrid cloud deployments, and security is often just scrambling to understand what's even deployed inside of their environment in the first place, because you can't secure what you can't see. Then there's the new risks we have to consider. Things like exposed secrets, overprivileged identities, public exposure, lateral movement, your classic vulnerabilities and malware. Oftentimes we'll see businesses have 5 to 10 different tools to cover those various risk domains. And then security teams have to try and prioritize the risk, which often takes hours, if not days. And by the time they finish that prioritization work, there's already been new risks introduced into their cloud environment. So it's like a never ending game of catch up. Then there's the ownership model. Who actually owns the security? Is it just the job of the security team? Cloud environments are quite large. And in order to be effective, oftentimes you need collaboration between developers, infrastructure folks, DevOps folks, the SOC team, IR teams. And it's hard to bring that collaboration and make it happen. Now, agility is one of those things that has been the reason the cloud has been so widely adopted by businesses. They're able to quickly leverage new architectures, new technologies, offer better business value to their customers, all with the click of a button. That same thing that makes it so great for businesses also is what makes it so challenging for security. Security is constantly dealt with having to secure new services, new architectures, new assets that are being spun up constantly. And it's basically a never ending game of catch up. The problem with that is they don't have time to work on new security initiatives. Things like taking a zero trust approach and limiting access of identities and removing super users altogether. But they don't have time for those sorts of initiatives because of how fast their cloud is growing, and they're just trying to do their best to keep up. Now, exposure, as always, has remained a key risk in the cloud, but now it's two-pronged. There's the public exposure we're all probably familiar with, but now there's also identity exposure. Here on the screen, we see a couple examples of notable recent data leaks. And it just goes to show that it doesn't matter if you're the largest organization in the world down to the smallest, it's easy to leak data. And that's because of the agility of the cloud. You can spin up assets with the click of a button, but it's really easy to introduce misconfigurations and leave assets exposed that you didn't mean to leave exposed. We found that over 55% of companies have at least one database that's publicly exposed to the internet. Now, attackers haven't been sitting still during this cloud adoption. They've become increasingly clever with their attacks, and this has led to the birth of what's called toxic combinations. An example of a toxic combination could be an workload that is publicly exposed, that has a secret on it, that allows lateral movement to an identity, compromising some sort of sensitive data at the end of the attack chain. Toxic combination in that case is essentially just a combination of different risk domains, things like insecure secrets, the identity supply chain, weak authentication, excessive privileges. And the combination of those things, or that toxic combination, makes it really easy for attackers to compromise environments. A couple notable examples here. In identity supply chain, we have Nobelium. For insecure secrets, we have the House keychain attack. And for example, with weak authentication, we had Extra Replica, which allowed users to break down cross-tenant isolation in a cloud provider. Now, let's take a look at a real-life cloud attack. In this case, we have a pretty standard setup that looks pretty secure, all things considered. In AWS, there's subscription A. There's a VPC in that subscription, a subnet. In that subnet, there's two different security groups that have their own sets of resources. And then there's subscription B with its own VPC, subnet, and EC2 instance. And it looks like there's no sort of peering between the two. All in all, this looks fairly secure. Now, typically attacks begin with some sort of initial cloud access. In this case, the cloud access occurred in patient 0, which is an EC2 instance running Apache in subnet 1. Then what occurs is an attacker gets access to that EC2 instance. They then essentially start looking through the various secrets that were left on that instance to see what permissions they had in the environment. They saw a get user, a list buckets. Those were denied. However, they were able to actually create a user via one of the secrets. And to escalate their privileges on the resource, they actually leverage the dirty cow malware, which allows you to escalate your privileges on Linux machines. After they created a user in the environment, this cloud is pretty much compromised. They created their own user that had its own set of permissions and essentially were able to laterally move over to that other security group that has that RDS table. So you can see how even if things look secure on paper, it's pretty easy for attackers to compromise an environment, and it's not just configuration on its own that lends itself to security. In this case, after the initial access, we saw how the attacker created a user and then moved laterally over to sensitive data that was then able to exfiltrate. And this is an example of an actual attack that has occurred. Now, if we try to break this down and look at a common attack path, essentially we see three steps that attackers take. It begins with some sort of initial cloud access. That could be through some sort of public exposure or maybe an API key they found in a GitHub somewhere. Then attackers will look for lateral movement in the environment. It's land and then expand. When they expand, they're essentially looking to eventually reach up at some crown jewels. Once they reach the crown jewels, it's game over, data is exfiltrated, and the business has been compromised. An example of this occurring recently is the Team TNT attack. In this case, they followed the steps of finding initial cloud access, which came in the form of a container. Once they got access to that container, they moved laterally in the environment to look for the crown jewels. Once they found the crown jewels, they didn't exfiltrate the data right away, which would have alerted the security team. What they actually did was they deployed a decoy miner to a container to distract the security team while simultaneously exfiltrating the data. So you can see how attackers, by leveraging these toxic combinations, are quite clever in how they're attempting to exfiltrate sensitive data from businesses. Now, if we take a step back and think about high-level security goals here and what we could have done. Before exposure, our goal should be to proactively remove any and all attack paths. That's any public exposure, any overprivileged identities, any secrets that may be exposed. You want to, of course, clean up any vulnerabilities and malware that exists in our environment. But we have to be practical. We talked about agility earlier and how fast the cloud grows. So at some point in time, something may slip through the cracks. Post-exposure, we want to be able to detect and limit the blast radius of any potential incidents. Ideally, we want to stop attackers as early in their attack path as possible. In this case here, we'd like to stop them at initial cloud access. We don't want them to get to lateral movement, and we definitely don't want them to reach our crown jewels. Now, if we want to formalize a strategy, we can look at the defense in-depth strategy. It begins with prevention, which is the best medicine, and ends with detection and response as a last line of defense. When it comes to prevention, we want to shift left as far as possible. We want to scan across the CI/CD pipeline, looking at the build stage, the deploy stage, and scan for vulnerabilities, secrets, and misconfigurations. Even, we should give developers the access and the ability to scan their code they're writing to look for misconfigurations or any vulnerabilities and secrets in container images they're creating. When we look at misconfigurations, that can be things like, for example, in a Terraform file, maybe somebody's creating an S3 bucket and they accidentally left it publicly exposed. When it comes to secrets, that could be things like a clear text API key or just a text password they left inside of an IAC file. We, of course, want to be scanning our cloud environment and looking for any and all potential attack paths across the variety of risk domains. We also want to be scanning our workloads and looking for vulnerabilities, malware, any secrets that may have gotten through our CI/CD pipeline, as well as for any potential risky configurations. Then beyond the prevention, we need to actually be detecting things in real time. We need to be monitoring our cloud events. What's occurring in our CloudTrail logs, our Azure Activity logs? Is somebody creating access keys, assuming roles they don't typically assume? And then we also need to have some sort of sensor on our workloads to detect real-time alerts, things like malicious activity, malware that's been deployed, crypto miners. And then beyond just detecting these things, we need to be able to actually respond to them in real time, especially at scale during breaches. Now let's take a look at an example here. In step one, we have the real-time monitoring detection of threats and malicious behavior. In this example, there's a container that's connecting to a crypto mining domain. We need to be able to detect these sorts of connections, as well as things like remote code execution, malware, lateral movement, container escape. We need to be able to detect both known and unknown threats. Now, once we've detected a connection to a crypto mining domain, what then? We need to take a look at context and understand, hey, if this container is being compromised, what impact would it have to the environment? In this case, we can see the container has an exposed secret on it. It looks like it has access to a role that has access to a database with PII data. All in all, this is pretty bad. The container has that crypto miner installed, and the role is attempting to escalate its privileges. So we can tell this is probably an actual breach that's occurring to our environment. So we need to be able to respond to it. We need to be able to isolate the container and kill the process running the crypto miner. And we also need to remove the sensitive data access that role has. It begins with detection, followed by context to understand risk, and then finally finishing with a response to it to prevent any breaches that occur. Once again, the goal is to catch these as soon as they occur and as early in the attack path as possible, so attackers aren't able to reach our crown jewels or move laterally in the environment. Now let's revisit that Team TNT attack we looked at earlier. And let's pretend we're a security team with a traditional siloed approach. So we probably have some sort of container security tool and some sort of identity access tool as well. In this case here, for the Team TNT attack, our container security tool might have flagged a connection to IMDS, as well as some suspicious network connections. Now, for anybody who's actually looked at container security tool, oftentimes you'll have thousands of these sorts of alerts when you have containers at any sort of scale because a connection to IMDS is pretty common. Now, let's say elsewhere in the environment, there's a cloud identity performing some sort of enumeration attempts. Maybe it's doing some configuration changes or some other suspicious events. Those on its own are also typically low or medium alerts and happen quite often. So not something we need to be typically concerned about. To make matters worse, the container security tool is often managed by the container security team, and the identity management tool is oftentimes managed by the IAM team. So these two tools are separate, spitting out their own alerts and managed by different teams. So in this case, in this Team TNT attack, we probably would have been compromised. But what if those tools actually were correlated and we were also looking at the larger cloud context to understand how the container and identity were related? Then it would look something like this. We see the container is publicly exposed. We see that there's a service account that the container has that gives access to that identity, and that identity happens to have access to sensitive data. Now, when we see those typical low or medium alerts, they're actually critical in severity because we can actually see an attack path from the container to a database with sensitive data. And you need to have this sort of correlation to cover the end-to-end attack path to allow us to effectively respond and detect to threats. And that's the Wiz approach. It's a unified cloud security approach to cover you from prevention to real-time detection and response. Prevention begins with understanding the full cloud context, looking at network exposure, identity exposure, overprivileged identities, exposed secrets, vulnerabilities, malware, and trying to remove as many of those attack paths as possible. We want to try and get rid of all critical toxic combinations, but then of course you need the real-time detection and response because, as we mentioned, people move fast in the cloud and new security risks are constantly popping up and something will eventually slip through the cracks. And we need to be able to monitor our cloud and also then detect any potential breaches in real time. Now let's take a look at another example here. In this case, we have a privilege escalation attempt that's occurring on an EKS container. Now, what you'll notice here in the evidence on the right-hand side is there's some sort of connection to IMDS, a pseudo process that was executed, and an access key that was created. What you'll also notice is that two of those events are coming from a runtime sensor, and one of those is coming from CloudTrail logs. What we've actually done here is we've combined runtime signals, cloud activity, and audit logs to turn those on their own low-fidelity alerts into a high-fidelity threat detection. By doing that, we're able to actually uncover attacker movement in our cloud and respond before attackers can reach the crown jewels. If we remember the Team TNT attack we looked at on the previous two slides, the container security tool and the identity tool, they were separate. In this case, we looked at both avenues and correlated those outputs together to turn this into a high-fidelity alert that our SOC and IR team actually cares about. Now, the IR teams and SOC teams have been alerted and they want to figure out if we're actually being breached. So they leverage our forensics capabilities to understand what's going on. In this case, they notice by looking at the process tree that the node and container maps all the way down to a process that occurred on the container that created the access key. Then if we take a look at the user account, they can actually understand the blast radius that occurred. In this case, they look at the impact analysis to understand if this user account was compromised, how would that impact my environment, and then also how would this have occurred in the first place via the root cause analysis. The process tree and the blast radius go hand in hand to give SOC and IR teams a good idea of what occurred and why it occurred and how. Now, after they've ascertained that this is indeed a breach, they were able to also, through Wiz, respond to the attack. In this case, they isolated the VM hosting the container, as well as then removed the excessive access permissions on the identity so it wouldn't have access to the sensitive data. By isolating the VM, they would potentially stop the attacker there, but just to be safe, they isolated the identity as well. Once again, if you think about this example, we've started from the beginning by detecting a high-fidelity threat detection and then giving the ability to investigate what occurred via forensics, and then finally responding to the alert as well and stopping the breach from occurring. Now, if we think about this at a high level and the benefit Wiz brings to the organization here, first off, it's the fact that everybody's leveraging the same platform. You have developers leveraging the platform, you have platform ops, cloud security teams, IR and SOC teams. With everybody leveraging the same platform, it encourages cross-functional collaboration, which is amazing for stopping threats. Rather than having various point solutions, if you just leverage Wiz, everybody speaks the same language and communicates in the same way, allowing everybody to effectively respond to threats, and everybody now owns security rather than it falling solely to the cloud security team, which at at which the cloud grows makes it almost impossible to completely secure the cloud. Just some background about Wiz now. We're happy to say that we support over 35% of the Fortune 100 in securing their cloud, and we were rated the leader in cloud native application protection platforms, or CNAPP, by G2. With that, I'll thank you for your time. Please come see a live demo at wiz.io/demo.